Okay, this is the second example question that I want to do. This one's actually a bit closer to what happens if you do take data, because it does show data points, but we don't actually need them in this for us to work out what's going on. So the fact the points aren't there are just there for realism. So again, we've got another exponential graph. We're not sure what the graph is doing yet, but because it's a positive one, I'm suggesting the graph will probably go. Just draw a little sketch. So they've done the log of t and n. I suspect that the n and t are going to be linked in some way like that. And they're going to curve up. Things we've got to do is, first of all, do the equation of the line again. Use the information to estimate the number of microbes present in 3 days into the experiment. So let's put the numbers into the expression. And with reference to the model, interpret the value of what A means. Okay, so we've got a value here. This time, notice t to the b, yeah, so it's the gradient one again. So doing question A, we are show the relationship can be expressed in the form of log 10 n equals m log t plus c, giving m and c in terms of constants. Well, with this sort of question, I will always start with what they've given us and try and demonstrate that I know where the expression came from, because it says show this relationship can be. So it's not just finding out what A and B are, or what MA and B. We need to actually be able to prove it. So let's create our equation. So this one actually involves a proof. So we're being asked effectively to prove the relationship between the two equations. Take the log of both sides, and I'm going to say log base 10. Because they've written log 10 here on, it's important that I actually do say that I am saying, when I say log, I mean log base 10. It simplifies my writing for me. You can write it out fully if you want, but if you're going to redefine something, say so. And let the examiner know. And do the log of both sides. And then you expand the logs on this right hand side. So we've got log base 10 of A plus, and for this one, unlike the last one where I expanded things out, I would show each step. So I'm now doing log base A, log A plus B log T. If you want to go fully, we've got multiplication rule, and we've got the power rule. Okay, so if you comment on that, you're going to get the same marks. So now we're going to compare this with log n equals c plus m log t. So m equals b, and it says m in terms of A and or B. So m is b, and c equals log base 10 of A. So we've got our first question there. I'm not sure what that beep 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 means. Hopefully it doesn't mean I've done anything wrong. So use the information provided to estimate the number of microbes in 3 days. So the first part we've got to do is actually find out what C and M are from the graph. The first thing we can look at is C is going to be on this scale. Looking at the dots, there's 2 small squares for every 0.1, so this is about 1.8. So C equals 1.8, and on the exam I would actually, I'm just going to take a copy of the picture. I think I can do it that way, so I can add it to my notes. There you go. So we've now got, I can move into here and just put a little note saying there's my C, and the gradient is going to be from there, and I'm going all the way up to here. So I'll read across, and I make that 4.6, also 1.2, 4.6. And this C is at 0 and 1.8. That's the information I'm going to use. And of course we've got the standard gradient function, y over x. When I'm talking about exam questions and things, I normally will try and draw my triangle that way up to remember y comes first. So now I put my bits into my equation. There's a change in gradient, 4.6 minus 1.8, divided by 1.2 minus 0. Oh, it's one of my other things is beeping. It's a microphone. So I record all of those, and we get 2.8 divided by 1.2, which, according to my calculator, 2.8 divided by 1.2, which is 7 over 3. Silly blooming thing. And I need my pen again, which is 7 over 3. So that's giving me my parts. I can now put these into the equation. So n equals, why is that beeping? 1 power. Stop it beeping for now. So n equals little a. So a is c. Let's remove those two. So a equals 10 to the power of 1.8 and 10 to the power of 1.8 is 63.1. So why am I saying 1 point? See 1 point. Yeah, 63.1. As it's a model, the 0.1's okay at the moment. So we get our final thing, which is n is equal to 63, our starting number of bacteria, times the, or it's a model, we don't necessarily know it's bacteria, do we? Oh no, microbes, so it is a number. So 63 times our value of t to the power of 7 over 3. Put the value in when t equals 3. 7 over 3. Multiplied by 3 to the power 7 divided by 3 is 818. Because it's a number of microbes, that's why I've rounded this to the nearest microbe. And I would expect them to accept any integer values for it. The mark scheme's a bit vague on this question, to be honest. Okay, let's have a look at the last part of this question. I've just been checking out the video that I'm trying to build. That's what I just saw there. We need to interpret what the constant a is. Now, there's a lot of people will leap to saying that this is what happens when time is 0. But remember that a is the value 10 to the power of c 1.8, and that's when log of t equals 0. Rearrange that and you get t is equal to 1. So this is actually the value of microbes at the end of 1 day. Okay. It's not the same as doing the exponential graph. It's not the start, it's what's happened after 1 day. And hopefully I can see that on a graph. Where's my graph? There. Let's change the scaling a bit. So I want the y minimum to be about -5. Go 0 to 3 for that way. Come on. Get off, I just want 0. To 3. And from -5 to, let's go for the 300. See, we should see the 3 days. So that's my graph. Let's hide it. And notice the 63 value comes at the end of day 1. So this is actually that graph there. That's the point they're talking about. It's the end of 1 day. There we go, the end of the example.